He liked nature very much. He knew many species of birds, their appearance, and could distinguish them by voices. We couldn't. And we used to walk for several hours. In winter, we often went skiing. My first story will be about raincoat. When I was between 5 and 10 years, we usually spent part of our summer vacations by going on kayak trips for 2 or 3 weeks, usually in the company of families of other university professors. So here are these kayaks. These were portable kayaks that had to be assembled on the shore. We used to go down along a river or a system of lakes in the central zone of Russia. If the place for the camp was good, we stayed there for 2 or 3 days. Once, our group was about to move to another place, and the people were gathering their things and putting them in their kayaks. At this moment, my mother noticed that the day before my father went for a walk in the forest for about 2 hours, and lost his raincoat somewhere. This raincoat was very necessary in the kayak trip. My mother told to my father to go back into the forest and find this raincoat. All other people in the camp had to wait, and in fact they became a little bit angry, because everybody thought it was impossible to retrace the path. However, my father returned soon with his raincoat, and we were caught by a very strong rain the same day. So here are some other pictures from our kayaks trips. Here is our family. The next story is about the collaboration and friendship with Vadim Glazer. The members of our summer expeditions on kayaks were mostly mathematics professors and their families, as I told. However, my parents had friends among members of many professions. Among them there was an oceanologist, several philologists and linguists, and a physiologist, Vadim Glazer, about whom I will speak now. All they are very interesting persons, and my brother and I benefited a lot from conversations with these people. Now I am somehow lacking this intellectual climate I had in my childhood. Vadim Glazer was trying to understand the mechanisms of vision. One more about kayaks. Here is my father, Vadim Glazer, and the wife of Vadim Glazer, Lydia Vasilyevna Bandarka. And this was one of his main research interests of Vadim Glazer. He and his wife were among the best friends of my parents. Vadim Davidovich Glazer worked in Koltusheral laboratory of the Pavlov Institute of Physiology. I believe he experimented mostly with cats. They made this cat quiet with some medicines, introduced electrodes in his brain, and were showing him pictures with his bright eyes open. They were capturing electrical signals from a single neuron in the striate cortex, and were measuring the what is called the corresponding receptive field. The response of this neuron depends linearly on the signal, and this expresses the integral of the signal, the visual signal, against a fixed weight function defined on the plane. And so the receptive field is basically the region where there is a response. That is, it is just the support of this function. And what happens is that my father was continuously giving mathematical consultations to Vadim Glazer. This usually took place during our walks. If Glazer and my father were speaking about mathematics, the women usually kept their distance. But I often listened to these conversations. As Glazer discovered, the sizes of receptive fields were very different. My father suggested to Vadim Glazer an idea that the corresponding weight functions or response functions could have some properties of the Fourier system of functions on the plane. Probably we can say that they are something like wavelets. Vadim Glazer was very surprised when he found experimentally that the response functions took negative values at some points. As my father explained him, one cannot have a complete orthogonal system on L2 of the plane consisting only of non-negative functions. By the way, Vadim Glazer published a book in 1995 which is called Vision and Mind. And in this book he summarized the results of many years of his work. So this is some meeting, and here is some books I was already speaking about, and here is this book. The next story is about the Mужество square. And in fact, as I said, my father oriented very well in the forest, and in fact he oriented better in countryside than in town. When they bought a car, he became lost in the town while he was driving it to the garage. It was not so far, but there was the Mужество square on his way, which has 6 exits. So here is the Mужество square, and in English it means something like carriage square. And so he was just returning to the square again and again. Finally, the policeman noticed him, and the situation was turning to be unpleasant. But then my father decided just to orient by sun, and and then he found his way quickly. The next story, which I also think characterized my father, is about Громыхалова Street. This is about the noise which bothered us in our countryside in Komarovo, which is located about 40 kilometers north to St. Petersburg. This house was rather small and was close to both railroad road and an unpaved road called the Громыхалова Street. And in Russian this sounds something like a noisy street. This road led to a scrap heap, помойка. And so the lorries were running on it all the day from the early beginning. We knew when they started their running. And so my father decided to force this railroad away from the house. How he did it. He removed trees from one side of this road and planted them on the other side, closer to our house, and in fact almost on the road. I repeat that it was an unpaved road. So he was forcing the lorry drivers to change their way, and so consequently the road began to move. He continued this activity probably for 2 years. Then the asphalt was put on this road, and so he couldn't continue doing it anymore. But the road already has shifted by about 5 meters away from our house and from the fence. And then my father planted more trees between the road and the fence. Here is probably some view near Komarovo, because there were many pine trees there. And my next story is about hedgehog. At that time, in the 50s, the mathematics and mechanics department where my father worked was on Vasilievsky Island, in the central part of Leningrad, now St. Petersburg. Once he was told that he was called to the dean's office. When he entered, the dean told him that my father was accused of stealing. Specifically, there was a gentleman accusing him of stealing a hedgehog. My father hesitated, and then he had to admit that it was true in a sense. A few days before that, as he was returning from work, he saw a hedgehog on the line 10 of Vasilievsky Island. Without thinking much, my father caught it with the help of his hat and then brought it home. In fact, he was thinking of bringing this hedgehog to the forest and leaving it there. He didn't think that this hedgehog had an owner. However, there were some witnesses, and with their help, the owner of the hedgehog identified my father. But luckily, the hedgehog was still at our house and could be returned to its legitimate owner. The next story is about swallows. I can recall more stories about my father and animals. In more recent years, my parents had another country house in the Stroginov village in the Pdov region. And by the way, my father died there. Swallows used to make their nest on the outside wall of our house. That summer was very hot, and this hot weather continued for many days. And therefore, the nest dried and fell. Swallow nestlings were crying, and their parents were flying around and also were crying desperately. And then my father acted in a very, very determined way. First of all, he urged my brother and his friend to give water to the nestlings. My brother was about 10 years old. Then he took some straw and used it to build a nest. He climbed a wooden staircase and fixed the nest on the wall with the help of nails and hammer. Finally, he placed the little ones into the nest. It is believed that if the birds pick up a smell of a stranger on their nestlings, they reject them, and the little ones will die. And there were neighbors who were predicting that. This story, however, had a happy end. In a very short time, the adult swallows began to bring food to their nestlings, and everything continued as if nothing happened. We watched how the swallow nestlings finally learned to fly, and in the autumn the whole family left the nest. Okay, the next story is about squirrel. In our countryside in Komarova, the first countryside, there were many pine trees and also many squirrels. In fact, we had a feeder outside of one of the windows, which was thought for birds but mostly visited by squirrels. Once my mother saw my father running after a squirrel, and squirrel, like this one, was escaping by the top of the fence and had an amanita mushroom in its paws. Muhomor. It has muhomor. It had muhomor in its paws. And my father was running after the squirrel and shouting, "Don't eat a mushroom, it is toxic." To conclude, I wish to tell you my father's favorite fable. The fable is about frogs, and probably some of you know it. There were two frogs, and both of them fell into jars with milk and were about to drown. The first one just accepted its fate, stayed in the bottom, and certainly died quickly. The second one decided to struggle desperately and jumped in order to breathe. And it turned out that the milk was fatty, and as a result of this movement, milk was whipped into butter. Then this frog could sit on this piece of butter until somebody took it out. Sometimes my mother was saying that my father's activity resembled jumping in feckless milk. But I believe that you can deduce from my stories it was certainly not the case. Okay, I finished just some few more photos of my family, my father doing this activity, my father with a camel, and it also has some short story behind. And these are last years. It was already mentioned in this conference then that when my father was already rather ill, they just decided to move the seminars to our flat. This is one of the seminars, and this is when they take tea after the seminar. Okay, thank you for your attention.
Any questions, comments? Thank you very much once more. So it is my special pleasure to announce our second keynote panelist and speaker, Professor Vladimir Rasvan. Many times, Professor Rasvan said he is personally contacting those Vladimir Yakubovich and his Rasvan group. So this gives background. There is not going inside from the outside and inside.
Well, it's a great honor and pleasure to speak about the legacy, the contributions of Vladimir Andreevich Yakubovich and their influence in my country, science, control theory and applications. Because now thinking about how, let's say, step by step this influence established itself, this sent me to a novel by Vasily Grossman, Life and Fate, where it is written somewhere that if some people have to meet each other, even if they are very far away in time and space, finally they succeed to meet themselves. And it appears to me that somehow this is the case with influence and contributions of Vladimir Andreevich in Romanian science. In order to make this clear, I would like to present you, as one could see, the Romanian context of the early years to show you that Romania didn't have a systematic tradition in the field of differential equations, and of course not in automatic control, which was at its beginnings before the Second World War. To speak about the early years of the 50s, the golden years of the positivity and the hyperstability, and the spread years up to the next century and millennium, that is by now. So first of all, let me show you the first influence of the St. Petersburg mathematical school, that before the First World War, the Second World War, the journal circulation and language obstacle made the contact between Russian and Romanian mathematics very, very weak, with notable exception of the Miller Mathematical Seminar of the Iași University. In fact, this seminar is called seminar, but it's a huge library, and it was founded by Professor Alexander Miller, who was married with Vera Evgenievna Miller-Lebedeva, who was originally from Novgorod Veliki, and she studied, you may see the form, the Bestuzhev courses in St. Petersburg before the First World War, of course, and she met her future husband, who was from Romania, when they both were doctoral students of David Hilbert in Göttingen. And then they moved to Iași and lived all their life there as professors of the Iași University. So this is, in my opinion, our first connection with Russian mathematics. And worth mentioning that V.A.Yakubovich was the first woman to become full professor of a Romanian university after the First World War. And now I would like to say that the most notable results of Romanian mathematics in the field of differential equations are these papers of some Romanian mathematicians, which are cited in the renowned handbook of Erich Kahnke. The main thing is those who were published in Czernowitz, because they published most probably in German. They circulated, but also you may see important journals as Annales de l'École normale, Compte rendu de l'Académie de Roumanie. This was after the example of France, and other papers, all of them dealing with boundary value problems, except the paper of Davidoglu, who will deal with existence and uniqueness for special differential equations. We are studying special cases, nice from the point of view of the mathematics. Well, the turning point comes after the Second World War, with Professor Aristide Halanai and Professor Constantin Corduleanu from Iași, among whom Professor Halanai did his PhD in Soviet Union with Professor Dmitry in Moscow, and as it will become clear, it is here the first contact point with Vladimir Andreevich Yakubovich. You must remark that they belong to the same generation of people. Here I put Professor Halanai in order to remind him that we came together to Leningrad in 1991. Well, he visited the Soviet Union of the time several times, but this is just to make a remembrance. His candidate thesis was called Canonical Systems of Second Order and the Riccati Equation with an almost periodic coefficient. Or exactly at that time, he would cite, I don't know if in his thesis, but in a book published in Romania, the stability criterion for canonical systems of two equations with periodic coefficients, because at that time people had the strong belief that everything that is good for periodic is good for also for almost periodic. This turned not to be exact. On the contrary, as George Sell would put it, the history of the almost periodic is the history of overcoming a long chain of difficulties. And at the same time, this paper of Yakubovich, I totally was published in the was cited in the very first book of Professor Halanai of 1956, where he gathered his Soviet Union experience as the early years of his seminar at the Institute of Mathematics of the Academy. But at the same time, he is citing there two titles, a paper and a book belonging to Alexander Mikhailovich Lyotov and to Mark Aronovich Eiserman, dealing with early results and statements of the problem of absolute stability of control systems. And this could be found in a paper of Halanai from 1958, but I think was meant probably in 1957, where, judging after the title Soviet Research in the Problem of Stability of Control Systems in Romania, published in Romania, in the so-called Romanian Soviet Annals of the Romanian Soviet Institute of the time. And if I mention 1957, you could probably remember it was the 40th anniversary of the October Revolution. So this was an occasional paper, but nevertheless a professional one, stating problems and giving some results. And this makes the entry of the absolute stability problem to Romania. Well, one of the participants of the seminar of Havanai was Vasily Mikhailov, who was an electronics engineer. He brings the electronic engineer, very active. Around the same year, 1958, you must imagine the leader of the seminar having 34 years and Popov having 29. He published his famous criterion. And I wanted here to show that they were somehow synchronized at the beginning of the Lyapunov function approach, because Popov also started from a Lyapunov function approach. So he published a paper on a generalization of the stability criteria of Anatoly Isakovich Lurie in Russian. Remark that he published in Russian, in Revue d'Electrotechnique et d'Énergétique, and probably another version of the paper is the second one, relaxing the sufficient criteria of absolute stability, published in Automatica et Telemechanica, almost at the same time with, I don't know if it is not the very first paper of Vladimir Andreevich on stability of absolute stability, published in Vestnik Leningradskou Universiteta. You see for the equations of the indirect control. This means that they were studying what we like to call now the first critical case, with a zero root of the linear part. So this is they're crossing without knowing, of course, one about the other one. Now, I pass to this turning point, the frequency domain inequality of Popov and its consequences. It was conceived by Popov to encompass directly the case of the systems described by integral equations, thus covering the topics of the absolute stability of the systems with time delay and distributed parameters. In fact, he did not have in mind this idea, but rather being an electronics engineer, he was thinking in the input-output framework. You have some electronic device, you push there some signals, you gather the response, and you try to understand what is happening there. This is an electronic engineering principle valid even today when we use integrated skills. And this was a complete surprise for the people, because this is a very early paper which was published in Romanian, because this was so were the times at the time. The globalization was not a concept. And I must tell you that the followers on this line of integral equations were Havanai and especially Cordoleanu, and here Professor Gehrig, who took the same approach. But at the time, as I used already to tell in the beginning as a seminar, this was not understood because the bounded input, bounded output stability idea did not exist at that time in 1958, unless you don't count a strange cycle of 3 papers of Vinokurov in Izvestia Vuzov Mathematica in 1957, but as late Professor Havanai put it, listen, he told me, I do not read Izvestia Vuzov Mathematica. And this was the reason why this was not understood, but he told Popov, if you want to convince us, do it for differential equations. And in the next paper of Popov, because he wanted to give something new in comparison with the paper, he did it for several nonlinear functions and was able to prove that if the Lurie inequalities, Lurie equations, as you want to call them, the resolving Lurie equations, have a solution that is a Lyapunov function of the type quadratic form plus integral of the nonlinearity does exist, then his frequency domain inequality, to be sure, he proved it is valid, it is fulfilled. And here we come to the next stage, which is as follows. You have first the seminal paper of Popov on absolute stability of nonlinear automatic control systems, An invited paper due to Mark Aronovich Eiserman after the first IFAC Congress in Moscow, where Popov presented a paper concerning integral quality criteria for nonlinear custom systems. In Russian, presented his paper, and he found some followers in Soviet Union. For some people, these names of Barkin and Zelensovsky mean something, I suppose. And almost immediately followed the result of Yakubovich, the most difficult, more difficult than the first one of Popov, showing that the frequency domain inequality is a sufficient condition for the existence of the Lyapunov function quadratic form plus integral of the nonlinearity. It is this very short paper in Doklad Akademii Nauk of 1962 that gives him, in my opinion, absolute priority on this lemma. But unfortunately, the method of proof, which had to be put in 4 pages, is very difficult to follow, and for this reason, the paper is cited in the book of Halanai, Differential Equations, Stability Oscillations, Time Lags. And this is a translation in English, but you have the Romanian version in 1963, without any notable reference, unless you think in the 3rd chapter, where the absolute stability is presented, that is mentioned as a new completing result of the field and nothing more. Because of the method of proof, the chance, and maybe somehow the chance was, when the paper of Professor Rudolf Kalman was published, the method of proof of the same result was based on factorization of polynomials, and this became very clear to as a method of proof, and from this moment the lemma was adopted in Romania, especially by Popov, who generalized it to the multivariable case in what follows. The paper of Kalman was in 1963. It is used, it is applied in the paper of Popov, solution of a new stability, absolute stability problem, published in Automatica et Telemechanica, where he introduced for the entire world the notion of hyperstability, which he published in fact 3 years earlier in a small Romanian volume. The fact is that from this moment the proof of Kalman can be also explained, because he came from filtering, from network synthesis, as he showed us in his talk, and there in network synthesis factorization is basic. Well, to go further, the influence of Vladimir Andreevich in Romania, as I told you, was the paper, especially indirect by the paper of Kalman, and its immediate consequence were the work of a member of our seminar, Theodor Morozan, who used to work on stability of the system with stochastic parameters, showing exactly this idea. He used the Lyapunov function as a tool of proving theorems, but the effective condition to be fulfilled to check stability was a frequency domain condition, which was put on the results, and via the great lemmas we call it now, he was able to construct his Lyapunov functions. And the next step was exactly in those times. It was the development of Vladimir Andreevich of the method of matrix inequalities in the theory of stability of control nonlinear systems. The first part, absolute stability of forced oscillations, which was immediately generalized by Professor Barbalat and Professor Halanai. So, slowly but surely, langsam aber sicher, this influence started to be known. In any case, in 1969, when I joined the doctoral systems, the Romanian aspirantura, I was already pushed to read the papers of V.A.Yakubovich. And now I would like to speak about the hyperstability, because hyperstability is very closely related to dissipativeness and to the other results. It's a natural continuation, also from the electrical engineering point of view, of the results in absolute stability. And here you have the paper already I mentioned, his book Hyperstability of Control Systems. I cited here the English version performed by Springer Verlag in 1973, but in fact Popov prepared the foreign languages edition much earlier, and again in Soviet Union they were the first to translate it. It appeared 3 years earlier than it appeared in the West. And here you must see the first steps of the integral quadratic constraints, which are to be found in this paper of Vladimir Andreevich in Automatica et Telemechanica, which I already started to read for my PhD studies. But since at that time we were convinced that the lemma could be obtained for time delay systems, field of my PhD thesis, only by factorization that we didn't have, I had to focus on the method of integral equations, and so I would like to mention the paper, the brother paper of Vladimir Andreevich on the same subject, but for equations of integral equations of the control theory, which was less circulated because it was in Vestnik Leningradskого Universiteta, but at the same time, as you may see, and because it was not connected with the lemma, it was not so cited, but I used it for full in my PhD thesis. And now I am around to the final part of my exposition. Is what I call the spread year, that is starting from the end of the 80s up to the next century and our millennium now. The first one is what we would like to call positivity without positivity. That is, Popov called positivity exactly the properties connected with the lemma, but with some inequalities in the time domain, in the differential equations, and for this reason, sometimes we call lemma is somehow within the framework of the positivity. And the result was finally a book of Professor Halanai with late Professor Vladimir from the Polytechnical Institute of Bucharest, which is doing what is called, I called it positivity without positivity, that is to connect the frequency domain characteristics to some other property that is not, has not definite sign. Time is some kind of generalization. That this could be found also in this book, Generalized Riccati Equation and Robust Control, and an attempt to do the infinite dimensional Yakubovich-Kaman-Popov lemma is due to Martin Weiss, who did his PhD in Groningen with Ruth Curtain, and unfortunately he did not publish his result of the thesis, except something in this book. He is now working in some other fields in signal processing. And in conclusions, I wanted to show you how we return back to the case of periodic coefficients and other results. That is the idea of continuous and discrete time parametric resonance. So we started by an addendum to the theorem of Vladimir Andreevich related to that paper in Siberian Mathematical Journal concerning what he called the lemma, but in fact it's, as he called it, the frequency domain theorem for systems with periodic coefficients on Siberian Mathematical Journal. We published a completion of the equivalencies there. Such theorems were very liked by Popov to prove closed chain of equivalence, and such kind of theorems are called now the roundabout theorems. But being invited to write a paper to dynamical systems of applications, we did something with Professor Halanai. This was in fact the last paper published together. You see it's published after professors passing away, on stability and boundary value problem for discrete time linear Hamiltonian systems. We started it as follows. I coined a question to professor, asking him how would be like the book of Yakubovich and Starzynsky, the Bible, in discrete time. All I am able to tell you is the following from the scientific point of view. Not everything goes, as we call mutatis mutandis, from continuous time to discrete. There are differences and difficulties. And this was the starting point of a program. You see another paper published by myself and Professor Halanai at a Crane conference in Odessa in 1997. And here I would like to mention the following. There are two things connected with Hamiltonian systems. Things that are connected with parametric resonance and Crane-Yakubovich-like results for Hamiltonian systems. They deal mainly with totally stable Hamiltonians, that is, who have the multipliers on the unit disk, the unit circle, while the frequency domain theorems and the results concerning with stability and optimal control, they deal with dichotomic Hamiltonians. That is, if they have the multipliers inside the unit circle, the counterpart will be outside from symmetry properties of the Hamiltonians. Well, these were, as I could tell you, the last results. I didn't cite here a paper on discrete time parametric resonance because it's not very elaborated. I am turning to it from time to time. And another thing were the periodic nonlinearity, synchronization, and several equilibria. Here is our common paper with Gennady Alexeyevich Leonov, because we were stimulated by the results on synchronous machines. And this is an aspirant, former aspirant of mine, who studied neural networks as systems with several equilibria. I wanted to show you that not only Vladimir Andreevich is influential in Romania, but the entire, a lot of people from St. Petersburg school. Thank you.
Any questions, comments? So let's Professor Halanai.
It's time to continue, and I will invite Romeo Ortega from Super-Electrons to present on the role of passivity in adaptive form.
Thank you very much. It's really a great pleasure for me and a great honor to have the possibility to talk to this prestigious audience. And I should say that one of the greatest honors I have had in my life was when I was invited to the seminar in the house of Professor Yakubovich about 5 years ago, I think. And I enjoyed the tea of Mrs.Vladmir, and for me it was an incredible moment to give a seminar in the flat of Vladimir Andreevich Yakubovich, listen to him and ask him, trying to answer his questions, which of course I couldn't, but it was a great honor for me. So with saying that, I would like to move to the talk, and I was requested to talk about passivity in the control, which is actually the starting point of my career. When I arrived to France for my PhD degree, my supervisor, Joan Landau, he was surprised that I had a book of Popov in Russian. And he said, how come you read Russian? I said, yeah, I read Russian. And I had the book of Popov. And he said, okay, he had already a book on application of hyperstability for adaptive systems. And I wanted to use the connection with passivity. So hyperstability for me was too complicated. I couldn't understand it. what I understood a little bit of passivity. So that has been basically the route that I have taken along my life. So passivity is the word I use more often than any other one. So this is really a tribute to the seminal contributions of Professor Yakubovich. And I had the honor to host him in France, and he gave me some human lessons that I will never forget. So these are the contents. I would like to bring to your attention, I already mentioned in the talk of Sasha Fradkov the day before yesterday, that there are some works of Yakubovich in adapt control which are not well known, and I would like to bring to your attention these pioneering works, and in particular the work of recursive aim inequality. So yesterday Professor Bondarko talked about it, and he was one of the main contributors, and also the publication of a book. This is not working. Anyone has a pointer?
I guess the problem with the screen.
Oh, the screen, okay. And also a book written by forming Fradkov and Yakubovich that I had the pleasure to review. It was in Russian, it was never translated in English, and that book is really a book ahead of its time. So when I read the book, I said, wow, these guys were like 10 years ahead of the West, and in many, many respects. I would then move a little bit to more theoretical aspects, or try the error equations of adaptive systems that you are all well known, and just to underscore the role of passivity in the analysis of adaptive systems, which sometimes is overlooked. Sometimes people biased by the Japanese approach, they tend to forget that the underlying mechanism for stabilization of adaptive systems is really passivity. And not just for adaptive systems, but for many, many physical systems and many developments of control theory. Then I would like to talk about the result, which is more recent due to Peter Kotovic, which I believe to be one of the fundamental results also in control. Again, using, in this case, positive realism, which is the equivalent to passivity for linear systems. And finally, some personal recollections of Professor Yakubovich. So this is a fact, and I'm convinced about it because I spent quite a lot of time reading these two papers recently, and people claim that the first proof of global convergence, at least in the West, of an adaptive control algorithm is credited to these three authors. So there was an interesting story that 3 different groups published at the same time in the same issue the first proof, first in quotes, of global convergence of adaptive control. So the Mundin-Ramachin paper, Moore's paper, and the Anecdotes paper. Actually, historically, there was a previous proof by Polyak and Morse in 2 years before, but very few people understood it. I mean, the people who understood it was Kovacevic several years later, and it's the basis of backstepping. So Polyak and Morse's paper is based on backstepping. It's an adaptive control based on backstepping, and he had a complete proof in '78. But that's a little bit overlooked, and people claim that it's these 3 groups that had the first proof. But actually, looking into these 2 papers, '72, Vladimir and Dmitry already had a proof for relative degree 1 systems, and then extended it in 1976. You see, this was the 5th Life Congress in Paris, and in 1976 he had a general result for average relative degree. He's using this method of recursive aim inequalities. This is my translation, I don't know exactly what it is. This paper was never translated, it was in Russian, but the proof is there. You can really check the proof and it's correct, it's rigorous, of course. And well, it took 16 years to be translated into English. But you see the precedence of these 2 works with respect to the previous works. So I think it's important for people. I was asking the young guys in ITMO, who do you credit with the first proof of global convergence in adaptive systems? They say, well, Woodin, Ramachin, Keynes, or something. I said, no, man, you're wrong. It was Yakubovich. Then, interestingly, in those papers, he's already proposing the use of things that took 10 years in the West to think about. For instance, explicitly considered the presence of bounded noise. And to deal with that, he proposed the use of projections, dead zones, that were done in the West 10 years later. And then he also, in that paper, in the second paper at least, he asked the question about the sign of the high-frequency gain, which is one of the big questions in the West. It took a long time to find an answer for that. And he already was asking this question. So he was saying it's necessary to know the sign of the high frequency gain, which until now it is the case. So no one has been able to overcome that except with exhaustive search algorithms. Now these results and many others are well known in the West, and they were reported in this book. So this book for me was an eye-opener. I was in France doing my PhD, and I said, wow, all the things that are in that book are not yet done in the West, or are just people starting at that time to think about these problems of dead zones, projections, and so on. So the questions of robustness of adaptive control, which appeared in 1983, 1984, and so on. I had the honor to do a review to that book. And it's one of my most cited papers, by the way. So let me move to a little bit technical thing, just to show the equations that you all know, and the two main equations in adaptive control, just to underscore and highlight the importance of passivity. And I'm talking about what people call parameter adaptive control systems. So you have a plant, a linear plant, described by a transfer function, and a linearly parameterized controller. So this is what is called the regressor, and this is the estimated parameters, and your question is, I want to find a value of these estimated parameters to achieve some control objective. So for instance, there is some reference, I might want to track a reference according to some reference node. The key assumption for these kind of adaptive control systems is that there exists a good parameterization. So there exists some value of this parameter to the hat such that your control objective is achieved. And then your question is, how can I find that parameter via estimation? For instance, model matching is one of the classical objectives. What is called model reference adaptive control. So then what you do is you define a parameter error. So you define an error between the parameter that you don't know and the parameter that you're estimating. Actually, one of the contributions of Kalman, that very few people know, is that he was the first who imposed this, that we call now certainty equivalent assumption. So before that, there was a group in Russia, Feldbaum, and people working on dual control, where they said, okay, this theta hat is not the real one, so we cannot apply directly. So let's try to estimate ellipsoids and try to estimate confidence intervals, and that was a very complicated problem. So the dual control was a very complicated problem. Actually, when I came to France again, sorry to tell this personal stories, Landau wanted me to work on that, and I said, I'm sorry, it's too complicated for me. But fortunately, Kalman had this idea of let's just apply theta hat and forget about the fact that we know that it's not a true parameter. Let's see what happens. So what we call now certainty equivalence principle, which is an ad hoc application, of course. And if you do that, so you apply this parameter theta hat, and you create what is called an error equation. So basically, let me show you in the diagram, you have something like this. You have your plant, you have these two linear time invariant filters. Because of linear parameterization, you can split. Here you have theta hat phi, and then you create the error. So all this part of the system is a linear time invariant system, which is now called the tuned error equation. And then you can assimilate the effect of the parameter uncertainty by just an additive signal. So theta tilde phi, which is acting on what is now a invisible linear time invariant system, assuming that these are constants. So this is the so-called error equation, which is now standard defined in the book. So you end up with some transfer function, which is perturbed at the input by this theta tilde phi, and some y star. And these are called tuned, as I said, the tuned transfer function, tuned errors. For instance, in the model reference case, where you want to track the output of some reference model, you define this error y-m, and then the equation takes this form. And if you know the order of the plant, you know the relative degree, and so on and so forth, then this H star is just your reference model, and E star is equal to 0. And then you want to analyze this equation now in closed loop with your parameter estimation. So until now, we just talked about the structure of the equations, so just the controller parameterization. I haven't talked about at all about the parameter estimation. So then comes the parameter estimation, and the simplest is just the gradient estimator. Because theta star is a constant, theta tilde dot is equal to theta hat dot, because theta star dot is equal to 0. then you can propose the simple estimator. Just take the error, for instance, in model reference self-control, multiply by the regressor, multiply by some positive definite matrix, and just integrate. Well, it turns out, and this is the key fact, it turns out that this very simple system defines an operator from this input to this output, which is passive. So meaning that there is a constant beta that will bound from below the integral along all trajectories. This is an exercise in the book of the Soviet saga, for instance. Not in the context of our control, but what we're analyzing is this operator here. So this is the part coming from the parameterization of the control structure, but this is the estimate. So you have here gamma minus 1 theta to the dot, multiplied by gamma, integrated. You pre-multiply by 5, post multiply by 5, and now you want to give properties of this operator from this input to this output. Well, it turns out to be passive. It's very easy to prove that for any passive operator here, even nonlinear, pre-multiplying and post-multiplying by the same signal does not destroy the Passivity property. So this from here to here is passive. So immediately we conclude from the Passivity theorem that if this operator, in this case this transfer function, is passive or positive real, you will have a delta stability. So this is really the line mechanism of stabilization for adaptive systems. A similar property holds for discrete time. For instance, least squares estimators and so on. Actually, this was already implicit in the work of Fradkov, invoking a hyperstability instead of passivity, but in this clear form, in my understanding, was first presented by Katsuhisa. So this is the main method. So just some historical remarks. As I said, in Landau's book, he was using similar arguments invoking hyperstability, which is basically one-to-one. You can map one-to-one. Now, the celebrated, I should say, Yakubovich lemma, which is certainly one of the cornerstones of our field, allows to give a state space representation of that. So you make a realization of the transfer function H star, and these equations, I think these are the equations that have been most studied in the history of adaptive systems. I've seen them myself 10,000 times in many different, just Sasha Fradkov, I think he has written these equations 1,000 times, myself also. So these equations have been studied exhaustively from many different points of view, under which conditions we have exponential stability, issues of persistence of excitation, and so on. Okay. Now it's interesting, and this is just a remark. In my PhD thesis, I studied this same problem for discrete time systems. I had the pleasure to collaborate with Romeo, and it's a very different situation. So in discrete time systems, these operators are not passive anymore. You need to invoke something like least squares and introduce something that is called the dynamic normalization that open the road to robust analysis later on. So in discrete time, I have appreciated your comment. It's easy to say it's not mutabilis from continuous time to discrete time. It's very, very different situation. Actually, you can prove that it's not passive. You can prove that. Okay, the result I wanted to mention about average strict positive reals is the following. There was some preliminary very important work with Boris and Dmitry in 1985, where they show using some averaging analysis that if gamma is small, gamma being the rotation gain, then the behavior of the system with the phi inside will be approximated by this. So this is a simpler linear time-varying system. So this transfer function is acting only on the regressor. And then in a very important paper that actually there was a previous paper with Romeo and Quadratic, they proved the following result that I believe is very important. These things are just more technical, can be relaxed. So if the regressor is L1, absolutely integrable, persistent, exciting, and periodic, can be relaxed to almost periodic and so on. This transfer function is stable, then you have stability. You don't need the transfer function to be positive real. You only need it to be positive real wherever it's the regressor excites the spectrum. So if you do a Fourier expansion of this phi, if periodic field always exists, and you take the harmonic lines, spectral phi star, this condition will ensure that the system remains stable for sufficiently small adaptation gain. So this tells you Anecdotes is stability boundary, because you can prove that if you have more energy concentrated on the bad side of the spectrum, on the spectrum on the side where you have phase larger than 90 degrees, then the system becomes unstable. So I think this is a very fundamental result, and it's an extension of the classical result where you require the positivity or positive realness of the whole transfer function. You only need to be positive real, so phase shift less than 90 degrees, only on the side, on the band where you are exciting the system. So that's a very important, I believe, result. So let me just talk about some personal recollections to wrap up the talk. So the first time I met Vladimir, which was Sydney, you can see some familiar faces here, even my else, Sasha Fradkov and David Hill. And I think Sasha showed the picture similar to this, one of the Russian-Australian meetings that were organized in Australia. And I happened to be there, invited by even else. And I was fortunate enough to be invited for these seminars and some fabulous dinners in Sydney. Vladimir came to France, which is a lovely wife, in '96, and she spent, I think, about a week with us. And let me tell you a personal story that is really very, very representative of the human quality of him. We didn't have enough space in our laboratory, so we had to share the office. And I gave him, of course, my desk. He didn't want to accept it, but I said, no, please take my desk. I was sitting in another little desk and so on. And then we said, okay, let's meet tomorrow in the morning. We said, in France, it's very relaxed in the sense in the morning, maybe 9, 10. So I arrived at 10, and he was there at 9. And he was standing in the door, waiting for me. So he didn't dare to go and ask the secretary, please open the office for me. He waited for me standing on the door. So when I come, I said, please, I'm so sorry, I didn't mean to be late. But he said, oh, don't worry. I just stretched my legs for an hour or so. So it's really an incredible human being in that respect. So that's a humility lesson that I really appreciate. That's another picture. I unfortunately never wrote any paper with him, but he's playing me a lot of things that I appreciate from him. And then we went on a trip to the castle, which is called Chantilly. Here's his wife, my son, my wife, and Professor V.A.Yakubovich. It was a great time. And this was the last time I met Yakubovich before the seminar. It was a meeting in the North here in St. Petersburg. And this is one of these beautiful castles in the house of the academician next to the Evergreen. Thank you very much.
Is there any question for this one? Please.
Let me make a comment on your comment. You mentioned these certainty equivalence equations for adaptive control, and mentioned my name also. And yesterday you comment, you remember that yesterday the result we showed yesterday can be shown in 2 lines. There are different results. What you wrote today, certainty equivalence approach, we never did that. Never did that. It is also can be done by passivity, but we did different things. Because here the number of adjustable parameters is equal to number of unknown parameters. In our case, it is less. So it is reduced order controller. And although design is also based on Kalman-Poich lemma, but it's quite different.
Okay.
Maybe so. We may discuss it later.
Yeah, okay.
Yes.
Yeah, maybe wrong.
Well, before discussing this, I would like to add myself, because I was colleague with Lambda at the Institute of Power under Popov, most of us. He was studying adaptive control systems. It was in 1968. He was involved with some practical adaptive control of asynchronous squirrel cage electrical machinery. And he was shocked by, at that time there was a paper of a forgotten person, Patrick Parks, who was called the Apunov functional redesign of control system. And he wrote, read somewhere that the lemma will give, and hyperstability by consequence will give the most general Lyapunov function. And for this reason he switched to this passivity and control, because the earliest, simplest version of hyperstability is nothing more but passivity. That's what I to show that even another influence of Vladimir Andreevich that I forgot to mention. Thank you very much. Yes. I would like to invite Boris Petrovich Polyak to present his lecture of Vladimir V.A.Yakubovich and Convexity of Quadratic transformations.
At the opening session of our conference, Alexander Fradkov presented very nice review of research of Vladimir V.A.Yakubovich, and he tried to classify them in chronological order, in directions of research and so on. And it's not that easy, because there is a variety of themes in the scientific interests of Vladimir Andreevich, but I guess that it's also of interest to look at some general ideas which go through different works and which are realized, implemented in different times. And one of these ideas, one of such technical tools, was the idea of convexity for quadratic transformations. It is so-called S-theorem, or it's sometimes called S-procedure or S-lemma. And so originally this problem arose in absolute stability theme. The paper by Laurier and Postnikov of 1944 was mentioned here many times. And the notion of S-theorem was introduced by Eiserman in the book by Eiserman and Kampmacher. Now, well, as far as I know, this letter S doesn't mean anything. It is, well, just some function which is actually Lagrange function for the problem was denoted there as S function S, and then it was called this S procedure and so on. So mathematically the problem is very simple. There are quadratic inequalities. There are m of them. So when this set of inequalities implies another quadratic inequality, well, originally it was for two inequalities, and even for one. Actually, well, in the simplest form, it means when well, we have one ellipsoid, when can we guarantee that another ellipsoid with the same center lies inside this ellipsoid? So, in one side, it is absolutely trivial. If we have some numbers, non-negative numbers, such that this inequality is whole, and these inequalities for matrices are understood in matrix form, that is non-negativeness of the matrices, then definitely these inequalities imply this one. But is this necessary condition? And if it's the case, the S procedure is called lossless. Okay, so in the book by Eiserman and Kampmacher, actually the question was open, and it was solved first in this famous paper by Vladimir Andreevich of 1971. For the simplest case, well, when we have just one inequality, S procedure is lossless. Okay, but also in this paper there were given some extensions of these results, and later, for instance, Vladimir Andreevich proved a similar result for non-homogeneous quadratic functions. But the main idea there, and it was an unexpected idea, you see the formulation of S procedure is just, well, some algebraic inequalities hold or not. So it was the idea of convexity. If you look at this paper, there are some lemmas there which are exactly the result on convexity of quadratic images. And it is a long story about this, about results in this direction. And, well, for instance, Vladimir Andreevich refers to a paper by Dines of 1941 about convexity of image, of two-dimensional image, or quadratic image of the space. But independently, he proves the theorem, which was proved by Brickman in 1961, that the image of a unit sphere, 2D, quadratic image of 2D sphere is convex. And now, well, this, at the first glance, this S theorem looks, well, something special about inequalities and so on. But now it is one of the main tools in very different areas of control. For instance, when LMI technique, actually you see one of the conditions there was formulated as LMI condition. And now, when LMI technique is so common in control, maybe well, after this famous book by Poet and co-authors on LMIs, and S theorem is one of the main technical tools for LMIs. And also, it is very important for robustness results. For instance, if you have in mind what was later called structured singular value, or mu analysis, mu synthesis, S theorems plays very important role there. Okay, now a different stuff. It is about quadratic optimization. Suppose we have a minimization problem like this, where our cost function is quadratic and all constraints are quadratic. But what is important, we don't assume that these functions are positive definite, so there is no convexity here. Nevertheless, well, sometimes there are some properties of hidden convexity here. And again, Vladimir Andreevich was probably the first who discovered this hidden convexity property in this optimization problem. And for instance, there are several papers. I mentioned here just two of them, and one is by V.A.Yakubovich and Fradkov, and the second one of Fradkov, where all this technique was developed in all details. And so the result was very unexpected result was that for this non-convex problem, we have duality theory. Duality theory results, and it's based on convexity for some cases, on convexity of images of quadratic transformations. That's exactly what I mentioned before. And it's not a general case. Of course, sometimes these problems are indeed non-convex. But for some particular cases, for instance, when all matrices are commuting, or when there is just two constraints like these duality holds. Well, for instance, there is a very detailed survey by Sergei Gusev, which is called Fenchel duality and so on, where these ideas are deeply developed and explained. Okay. Now another stuff which was so yesterday there was a talk of Alexei Serafimovich Matveyev on applications of similar idea for infinite dimensional spaces. Well, I would say it was a real breakthrough when at the beginning of 90s, well, for instance, this paper is very well known at the West by Vladimir Andreevich, where it was assured that if these quadratic functions are not finite dimensional but infinite dimensional, for instance, they are quadratic integrals of quadratic functions, then we do have something like convexity of this image. Well, it was explained yesterday in detail by Matveyev. We have so-called almost convexity for arbitrary number of constraints. And it is absolutely unexpected result. And well, I guess that this result has, well, it's still not finished direction of research, and I guess that it will be will find many interesting applications in future. Okay, so I'll more or less stop here. So my idea was to show that in the cycle of papers for different years of work of Vladimir Andreevich, there were some general ideas, well, very unexpected. Well, there were geometrical origin on convexity, and this technique was exploited in several different works. Well, it was on global optimization, on Passivity, on quadratic linear quadratic regulators, and so on. But probably it was very typical for Vladimir Andreevich to have such deep understanding of underlying ideas in which unites very different fields of control, optimization, and so on. And let me finish with some personal comments. When you look at the booklet of our conference, you'll see the title Petersburg as a cultural capital of Russia. Okay. Actually, there is some understanding in this hidden idea that, well, Moscow is formal capital, but St. Petersburg is something more serious, more deep, more cultural, and so on. And actually, such competition was very common in Russia. Well, it was long-standing competition between Moscow and St. Petersburg. It was in all fields of art, of culture, and also it was in research, I would say. There was Moscow Mathematical School and St. Petersburg Mathematical School. And something of this sort there was also in control theory. There was Moscow School of Control and Leningrad School of Control. Well, there was, I would say, formal respect from both sides, but something, well, we don't believe them completely. But the exclusion was Vladimir Andreevich. Actually, I belong to Moscow School. I was in the laboratory of Tsipkin, but never there was any misunderstanding, any competition between, say, personally, Tsipkin and V.A.Yakubovich, and all of us felt great respect to Vladimir Andreevich. And you see how many people from Moscow are now here. And this is, I would say, it is our homage to Yakubovich. And actually, Vladimir Andreevich unites all the schools of control in Russia. And this is such positive person which just unites and never divides people and research. Okay, so thank you for your attention.
Any comments and discussions? So I would like to add a little bit. You mentioned the S procedure. In the very first paper of Postnikov, there is no S procedure,
No.
because it is the second critical case there with double zero root, and you don't need it. In my opinion, my remembering, the first place where the S procedure is mentioned is in the book of Malkin, Theory of Stoichkov Engineer, but he sends some paper of his in the 50s.
But, well, in explicit form, S procedure was claimed in the book by Eiserman.
I know it. But it's just S is just a notation of some function.
Yeah, just a notation. Well, people sometimes ask, what does it mean, S? Why S?
There's nothing.
There is nothing. Well, I don't understand why they didn't denote it by L, because L is for Lagrange function, and actually what was called S, it's just a Lagrange function for this constraint optimization problem.
I'm sorry, can I?
Yeah.
As I know, and I made a review of this in the paper, the first use was by Lumiere, but not in the Lumiere portion of the paper, but later in the book of Lumiere.
Yes, for the direct control, that is a basic case.
Yes, yes.
When
This
it's
was
absolutely
used
necessary.
the first time, but not in Lumiere portion.
So let's thank the speaker.
Good afternoon, dear colleagues. This was an interesting discussion about S procedure and character L. I'll tell you the truth now. Just I take a few minutes because I will continue this talk which I was asked to present by Professor Furuta by the next talk of mine, so I will save some time for this important topic. It's just better to do it now because it was a discussion. So I know what Vladimir Andreevich Yakubovich told about S procedure and L procedure. Indeed, character S was just because this function was denoted by S of nothing but occasion. And first time it was in a sense implicitly used by Romeo, implicitly in the book, later in his joint papers with Rosenwasser, and Rosenwasser has made it more clear, more explicit. And in the survey paper at the mechanical meeting published by Yakubovich and Gantmacher, they used as procedure. It was written there in the extended version due to Rosenwasser. And Yakubovich told that when Eiserman, or maybe Gantmacher, I don't know, when they were writing the book, they asked him how to call this procedure. He said, well, if you may call it the S procedure. So the term was coined by Yakubovich, first was used in the book, that's right, but the formulation was first used by, the trick was in the present form was first used by Rosenwasser before 1963. But what happened later? Later, that time they did not understand that it is closely related to duality theory. Maybe first time it was mentioned clearly in our joint paper with Yakubovich and in my paper of 1973, 10 years later. And in the most clear form, it was used, this duality ideas, in the works of Alexei Serafimovich Matveyev, related to convex programming and all this stuff. Kuhn and Tucker conditions, Slater conditions. And many years after that, again, this question, why S, was discussed. And Yakubovich said, I remember it very well, if I knew this duality, that time, first time, when this term was coined, I would call it L procedure, in memory of Lagrange and Fourier. But unfortunately now it cannot be changed. So we have to call it S procedure. And it also has some extensions. Just a comment on convexity. It's not necessary to have to assume or to prove convexity of the image itself. There can be the result can be obtained using convexity some more weak conditions, convexity of subgraph of function in the version of proposed by Savkin. Not many people know this paper, published in 90s in English, in the National Journal of Control probably. And also there are versions of Migretsky trail results for convexity of integral constraints in I would say, for the average integral constraint, averaging over time interval in our work with pollution. So this area, indeed, I agree with Boris Theodorovich, it's, how to say, неисчерпаемо, cannot, infinite area, okay?
It's full of open problems.
Full of open problems, indeed. So
Inexhaustible, I think is the best word.
Inexhaustible.
Inexhaustible.
Inexhaustible. Yeah, thank you. So sorry for this comment, but it was important to finish this discussion. And now, since Professor Furuta was not able to come, he asked me to present his talk. His talk consists of some number of pictures and comments. I will try to do the comments. Of course, I am not familiar with all the details, but I will try because some things are familiar to me. So the title of the talk is Professor and Mrs. Vladimir V.A.Yakubovich in Japan. And so this is first picture. Maybe just read the captions. Professor and Mrs. Yakubovich invited to the house of Professor Isidori at European Control Conference in Rome in '95. Maybe this picture was already shown by Alberto. Okay. And next year, 1996, when he visited Japan to receive IEEE Control System Award at IEEE CDC held in Kobe. Asakusa, we are visiting the market, the huge and very popular attraction in Tokyo for foreigners, Asakusa. And in another place with Professor Birdwell, University of Tennessee, who was at that time chairman of CDC. And probably he was president of the IEEE Control Society, if I remember. And so in the home of Professor Furuta, perhaps we are drinking sake. It was very pleasant to visit place of Professor Furuta. He had expressed a lot of hospitality. And next pictures are from CDC. This first I was shown already with Professor Utkin. The next one with Professor Lindqvist, Professor Zames, and Professor Safonov, from the right to the left. And the next one with Professor John Doyle, and with Professor Brian Anderson. All people here look very happy. And this one, same person and Professor Furuta himself. Also nice picture, I did show it first day. And this caption says, with ex-student, Prof. Ortega in St. Petersburg. I don't know what means ex-student.
I don't know. I wish I was a student. I would not be a student.
In 1997, at the conference chaired by Professor Fradkov, we agreed to apply to JSPS grant for his visit to TTEC, and he visited Japan in 1998. And this is in front of the Hermitage after the conference in 1997. Professor Gusev is here. And the Hermitage is here. And inside, maybe inside the Hermitage or inside the House of Scientists where conference took place with Japanese professors. And Mrs. Yakubovich.
And this Professor and Mrs. Yakubovich in Tokyo with Professor Kuchera in 1998 during his stay in Japan, he kindly supervised a graduate student named Nakamura, and we could write a paper entitled Tracking Domains for Unstable Plants with Saturating-like Actuators, asymptotic control. Okay, again, in Tokyo, but this writing is different, maybe it's not correct. And this one is in St. Petersburg, to be more precise, in Peterhof, near the palace, fountains, very beautiful places, with sons of Professor Yakubovich, Dima and Yura. Both are here. And sons of Professor Yakubovich. Yeah, this is the last picture. This is the end of my presentation for a talk of Professor Furuta. Maybe there are some questions or comments. I have a comment concerning the CDC conference and this procedure of ceremony of introducing IEEE control system aboard. Actually, in your program book, you have a speech which Professor Yakubovich gave at this lecture. And he was very careful with this speech. I have heard from Ekaterina Dmitrievna that he repeated it many times before his visit to Japan. And during his visit in Japan, last day before the procedure, the ceremony, we lived with him in one room, and he repeated it again and again and asked me to listen and to check some English things. So I'm aware of this speech, and after the ceremony, you know, when he went down from the stage, and I will show the picture when how he's giving this lecture, this speech. After the speech, I noticed that just like something changed in the world. People at the banquet, first all of them stood up and applauded. But then when he sat down, they started coming to his table and congratulating him and asking him to make photos with him. Just like first day of our conference with Professor Kalman. But in case of Professor Kamel, this was understandable for me at least, that young people, mostly young people, for them there was a great event, first time to meet great person, Professor Kamel, and making a picture with him maybe could be some contribution to their career, and not only just personal memories. But in case of CDC banquet, the people who approached Yakubovich were famous people, well-known, eminent scholars, and they came to him like students. And this was exciting for me. First time I understood how great was my teacher. So now let me pass to my presentation. Okay, we have some just time. just in time. In the beginning, I would like to say a few words how I knew about Professor Yakubovich first. I write about this in the paper, but just a few words. First time I heard the name Yakubovich when I was a schoolboy. I was interested in cybernetic. I was not, in my understanding, cybernetic was something different from mathematics. And I was going to create some artificial brains or robots, or to create them myself, and not learning some formulas. So I was going to study in Electrotechnical Institute University, but elder brother of my friend, my friend was going to enter mathematical high school, and which was associated with university, mathematical faculty of university, pushed me to enter the same mathematical school, explaining that the mathematical faculty, there is also possibility to learn cybernetics. Because there is a laboratory headed by Professor Yakubovich, and it is called the cybernetical laboratory, the laboratory of cybernetics. He said that it's hard to understand what they do, but the leader is very strong. That's why it would be good to go to mathematical faculty in order to get to this laboratory. In fact, I did like I was advised, and finally I entered a laboratory of theoretical cybernetics headed by Vladimir Andreevich when I was second year student. So after that there were many years of studying, cooperation, and just personal relation with Vladimir Andreevich, and I don't have much time to discuss, and I have too many recollections about him. Just I have prepared some number of pictures, and I maybe comment on them. Some of them are already were already presented on the first day, the first talk, so I will skip them, but there are many new ones. So, I don't know, maybe Dima already showed this. Yes. I don't know exact dating, maybe later we can. Nobody knows.
72 or 73. Not his age, but
Yes, we understand. So this dating 70s is okay, but maybe it can be specified. The country house later, probably this will be like, because in 70s we did not have color cameras.
Yes.
Did you show this one? No. Leonov yesterday was saying about that Yakubovich was conquering the tops, the peaks. It's a confirmation of that verse, and also Anders Lindqvist told that Yakubovich was brave man. It's again confirmation. And indeed, I should add that Vladimir Andreevich enjoyed making pictures very much. When we were traveling in several places, he was making pictures everywhere. And he actually was very good photographer. he spent a lot of time to to find the proper position, light, and so on. But finally, the result was perfect. Unfortunately, I don't have pictures made of him made by him. So that's why I cannot confirm this statement. But I think that's true. So I don't know when it was.
Also in the countryside.
No,
yeah.
it is not Petersburg.
Not
It's
Petersburg.
Our village, home,
Yeah, country house. Okay.
country house.
Sorry.
And it is the middle of summer.
Yes, yes. Best time for work. Summer is best time for work. I know. This with Ladezhinsky, also from your archive, I guess.
No, not from
No, this one I got from Professor Romanovsky.
Wow.
Professor Ladezhinsky was famous mathematician expert in partial differential equations. And this one, not sorry for bad quality, this has many recollections. This picture taken at the Zipkin's School on Adaptive Systems. Professor Zipkin organized every 2 or 3 years such schools in different places of Soviet Union. And they are very important for people working in adaptive control. Every time Yakubovich attended these schools, and he tried to bring young students or young researchers with him from St. Petersburg, from Leningrad, and there we were meeting. He already was a sort of head of Leningrad School of Adaptive Control, and we were accompanying him with pleasure, and we were discussing a lot of different things of science, of life, and these discussions were very important for us. And we met many people working in this area from different cities, like Moscow and other cities. And like here, this is pictures, confirmation that we were friends with Moscow researchers and with other researchers, because here to the left we have people from St. Petersburg, Derevitsky, myself, Yanchevsky, then Netushil, well-known author of some textbooks, then Yakubovich, bad quality, Kozlov, and Fomin. And it is taken in Lake Issyk-Kul, very beautiful place in Kyrgyzstan. So we were meeting and discussing different things with our friends in different cities. Okay, this is Yakubovich with Fomin. This is again, probably you showed this one, no? Somewhere in the mountains. Probably, I don't know where. Where?
I
Don't know. Yes, this is during visit of Professor Khalanai and Rasvan to... When?
This picture exists. This was in 91.
91.
April.
91. During the conference.
Conference on
adaptive system. Yes. 91. Yes, that's true. With Stivkin I had shown already this one, and this probably I did not show. The picture taken in Lund during first Russian-Swedish control conference organized in Linköping, and some people present here can be found here also. Some not, unfortunately. I know all the people from Russian side, but I don't know all of them from Swedish side. I know Björn Wittenmark and maybe nobody else. Maybe.
But it was the second school.
No.
not
First.
the first. The first was St. Petersburg.
No. No. In 1992 was the first school. It was. It took place in Linköping, organized by Leonard Jung, and then Russian team was moving to traveling over the Sweden to Stockholm, where there were some talks, and Anders Lindqvist accepted us, and then to Lund and to Göteborg, I guess. And that time in Lund, Professor Ostrom accepted us. We have some other pictures from that school. And the second one, the second control conference was in 1995, and it was organized by Professor Pervozvansky in St. Petersburg, 1995. The third one was every 3 years, 1998 in Stockholm, organized by Anders Lindqvist. So we met with our Swedish friend relatively often. So Sydney. So David is here. Yes. And this one I did not show first time. Another picture, and all these three gentlemen look very happy in Sydney. And this one Romeo showed already, also in Sydney. It was very pleasant days, and Yakubovich was very happy there. And after the workshop, we were traveling with him over Australia, to Newcastle, to Canberra, to Adelaide. And first in Newcastle, everywhere people were trying to make pictures with him. Here I can see Minyu Fu and Maria Siron. Unfortunately, quality at that time was not so good. And this is a place of Brian Anderson. And this is with Professor Koppel in Canberra also. Oh, this is very important picture. And the next one. Because after all this traveling is finished, we decided to go to Great Barrier Reef. It was an adventure, actually. Yakubovich pushed me to make this tour. I resisted, but I could not resist too long. So he said, Sasha, why not spend a few $100 for the lifetime experience? Indeed, it was how to say, after everything was finished, again, as many times in my life, it happened that he was true. Because it was so pleasant, so beautiful trip, that he also, many times after the trip, he told to many people how great was that trip. You can see we both are happy. This board traveling over between islands to Great Barrier Reef, and the next picture, look, we were swimming, and this small bungalow where we were living for 3 nights. When we came there, and it was not easy to order this place. That time, internet did not work. That time, it did not exist. Email was, but we did everything, every arrangement by telephone calls. And when we arrived to the hotel, this resort, small resort, near the seashore, showed our passports to the portier. He did not believe that we came from Russia. He said, oh, it's first visit of Russians to my hotel, and present us a bottle of champagne. So it was a great travel. I was very nervous, especially when Vladimir Andreevich was swimming. He actually was a good swimmer, and he was interested to see more and more. But I was afraid. I tried to be close to him, but I was not able to do it always. So I was nervous when he was far from me. And finally everything finished good. And next year there was a fantastic trip to Rome. Several people from St. Petersburg were at the European Control Conference organized by Professor Isidori. And after that, there were a few visits to other universities, to Siena and to Florence probably, and some trips. And this is a very important event, speech of Professor Yakubovich at the award ceremony, and the contents of the speech you have in your programs. This picture you already saw, and this one, what you didn't saw, this one, Božena Pasik Duncan, who was expected to be here actually, but the last moment she did not obtain the visa and was not able to come. This one probably also was not shown before. You can see David Hill in the back, and head of Harris McLammer, probably, if I remember. Okay, and this is the next conference in St. Petersburg. So every conference, you know, like this conference, we meet not only in the auditorium, but also at some receptions. And this taken in Stockholm. Yakubovich was visiting Anders Lindqvist many times that time, every year actually. And this is taken with probably Art Krener, if I remember. This is a place of Anders Lindqvist with his sons. This is already shown by Professor Furuta. Probably it was taken by Professor Furuta. This one probably I have shown before at the conference dedicated to 100th anniversary of Lurie near St. Petersburg in the suburbs. He is giving a plenary lecture. It was interesting to follow expressions of his face. He was trying to get us understanding the lecture with all the means. And this one is very rare picture, probably the only picture with Yakubovich and Roger Brockett. Is Roger here? I can send it later to him. At the NOCOS 2001 in St. Petersburg. Again, quality is not good, but again I can say that both gentlemen are happy, look happy. Two great men discuss great things. And this is a jubilee, his 75th anniversary. Some speeches given by Professor Gelik, Arkady Hemich was the first day and yesterday also here. And again, picture is this leaders of mathematics in St. Petersburg. Yakubovich and Stephen Boyd. And this is a picture, defense of diploma thesis at our Department of Theoretical Cybernetics. So many people I can see here also. And almost 10 years ago. Some of people here are students, like Mikhail Ananevsky in the corner, and now he is associate professor in our department, so we have some young generation. And Professor Praskurnikov, now he at that time also was student, and visit to Professor Kam. Did you show him or not? No. And this one I showed, have shown it. And this final picture from the seminar. We enjoyed these seminars at his place because it was a way to keep contact with great mind, actually, and great personality. Okay. Yeah, my final words are about all these pictures. You know, these pictures, maybe they are not of good quality, but they are very important. They were important for us, and they will be still important for us. That's why we are trying to make pictures when we meet with our friends in different places, because these pictures are signs of our communication, our friendship with thinking people with strong, interesting personalities. And probably this picture symbolizes the best part of our life. And I hope this, that if we keep this picture as a memory somewhere, it may help future generation to understand how interesting was our life, how the communication between people may help to make the life interesting and make science growing. Thank you for attention.
Is there any additional remark? If not, let us close the session. Thank you.
Thank you.
All of us for coming here. Remember once more. Being happy now. Very first.